Are you ready to track cryptocurrency prices in real time? In today's coding challenge, we're going to build a live crypto tracker using Go. Whether you're into Go programming or crypto, this project combines the best of both worlds. Let's jump in. We've got a package main statement, which is the standard way to declare a Go program. We'll use Go's built-in libraries, so there's no need for extra dependencies. We will use encoding JSON to work with JSON data, FMT for formatted printing, net HTTP to make HTTP requests, and time library, which lets us work with time units and do things like scheduling tasks. Here, we have a constant named API URL, which holds the URL of the CoinGecko API endpoint that provides cryptocurrency prices. Next, we define a struct to handle the JSON response. We'll focus on Bitcoin and Ethereum prices in USD. We have two structs here, crypto price and currency. The crypto price struct represents the overall cryptocurrency price data we'll be fetching from the API. It has two fields, Bitcoin and Ethereum, each of which is of type currency. The currency struct defines the structure for each individual cryptocurrency's price. It has one field, USD, which is a float representing the price in US dollars. So when the data is fetched from the API, it'll be mapped to this structure, giving us a nice organized way to access the specific prices we need. Alright, now let's write a function to fetch data from the API and decode the JSON response. The fetchPrices function is responsible for fetching the cryptocurrency prices from the API. It returns a pointer to a crypto price struct and an error. Let's see how it works. First, it uses the HTTP GET function to make a GET request to the API URL stored in our API URL constant. This function returns a response object and any error that might have occurred during the request. If there's an error, the function returns nil for the crypto price pointer and the error itself. Otherwise, it uses the defer statement to ensure that the response body is properly closed even if there are errors later in the function. Then, it creates a new variable of type cryptoprice to store the fetched data. It uses the JSON.newDecoder function to create a decoder object from the response body. This decoder object helps us parse the JSON data from the API into our Go structs. Finally, it calls the decode method on the decoder object, passing the address of the prices variable. This decodes the JSON data and stores it in the prices struct. If there's an error during decoding, the function returns nil for the crypto price pointer and the error. Otherwise, it returns a pointer to the successfully decoded crypto price struct, which will contain the current Bitcoin and Ethereum prices in USD. Now, let's look at the main function. The main function here uses an infinite for loop to continuously fetch and display prices. Inside the loop, it first calls the fetchPrices function to get the latest cryptocurrency prices. If there's an error fetching prices, the program prints the error message and exits. Otherwise, it uses the print function to print the Bitcoin and Ethereum prices in a formatted way with 2 decimal places. Finally, it uses the time.sleep function to pause the program for 5 seconds before fetching prices again. This creates a loop that fetches and displays cryptocurrency prices every 5 seconds, giving us a real-time update. Now run the code, and you should see the Bitcoin and Ethereum prices update every 5 seconds in the console. If you found this video helpful, you would like to watch other quick coding challenges on this channel. See you in the next video, and happy coding!